Questions 11 through 20 of the 2001 Grade 10 Cayley Math Contest. When a positive integer n is divided by 60, the remainder is 49. When n is divided by 15, the remainder is. So you've got some integer represented by n, and it's divided by 60. And you get some whole number, and you get a remainder of 49, like that. So if we isolate for n, we'll get 60 times that integer plus 49, right? Because that was the remainder. Now what they're saying is they want you to divide this by 15 and figure out what is the remainder. Well, 60m divided by 15 is 4m. And then 49 divided by 15, 49 is not divisible, but 15 goes into 49 3 times. And then 3 times 15 is 45, so that would leave a remainder of 4. So the answer for number 11 is C. The 6 members of an executive committee want to call a meeting. Each of them phones 6 different people, who in turn each calls 6 other people. No one is called more than once. How many people will know about the meeting? So you've got initially 6 executive members. These are the 6 execs. And each of them calls 6 people, like that. So initially you have 6 executive members, and each of them calls 6 people. So that will total 36, right? Because you got 6, 6, 6, like that. And then each of these will call 6 people. So 6 people each calling 6 means a total of 36, correct? And similarly, these 6 people will call 6 each, so that's 36. And so on, like that. So this row here is 36 times 6, which is 216. So what they want in the question is the total number of people that will know about the meeting. Well, the 6 executives, the 36 people that they called, and then the 216 people that were later called. And 6 plus 36 plus 216, the total is 258. So the answer here is E. The sequence is 3, 20, 37, 54, 71, and 16, 27, 38, 49, 60, 71 each have a 71 as a common term. The next term that these sequences have in common is, all right, so the first one is 3, 20, 37, 54, 71, and so on. The other one is 16, 27, 38, 49, 60, and 71, and so on. So they're saying that eventually there's going to be another term that's common to both sequences. All right, well, first figure out how do we get additional terms. Well, in the first one, it looks like the difference is always 17, like that. So to get the next term, we have to just add 17. So that would be 88. And similarly, in the next sequence, we have to figure out how do we actually get the next term. Well, this looks like each term is 11, the difference. So the next term will be 71 plus 11, which is 82. And there's a couple of ways of doing this question. There's the first way, which is just keep, writing down the terms, and, you keep adding 17 to get more terms, and then see how many terms we have to actually write before we get something common to both. The other way of doing it is by doing it with an equation. So let me just do it this way first, and then I'll do the equation way, and then you decide which way you would want to do it on a math contest. So the other one, you keep adding 11, right? So 93, 104, like this. 115, 126. And eventually the hope is that you're going to get a term that's similar in both. 159. So far I don't see anything similar. Keep going here. 203, 214, 225, 236, 247, 258. Oh, there we go. Finally, we got 258. So 258 is the answer to the question, right? But you might say, boy, geez, that's pretty laborious. Isn't there another way? And perhaps, here's another way I'll give you. In the first sequence, the nth term, you can easily figure out a formula, is 3 plus 17 times n minus 1, right? That's how you basically get the nth term. In the second sequence, the kth term will be 16 plus 11 times k minus 1. Now what we want is we want these to be the same. So we want them to be the same, so therefore you set them equal to each other, like this. Is equal to 16 plus 11 times k minus 1. All right? So if they're equal to each other, we'll get the same term. So if you multiply this out, you get 3 plus 17n minus 17 is equal to 16 plus 11k minus 11. So put everything on one side. 17n minus 11k is equal to 19. So if we can find integer solutions to this, we'll be able to figure out the term. So for example, when n equals 5, if you do the math, you will get 17 times 5 minus 11k is equal to 19. So that means 85 minus 19 is equal to 11k. And this looks like k is equal to 66 divided by 11, 6. So when n was 5, k was 6, the terms are matching. So n is 5, 1, 2, 3, 4, 5. K was 6, 1, 2, 3, 4, 5, 6. Correct. And then you use the same formula to figure out another integer solution, and that would be n equals 16. So that becomes like that. And solving for k, you get 23. So this is done by inspection. So when n is 16 and k is 23, they would match. So n is 16. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And k was 23. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. So I've done it in two ways. It's up to you. Which one do you prefer? Which one do you think you can do it quicker? So the answer to this question was C. In the rectangle shown, the value of a minus b is. So what I need to do in this question is draw some lines that help you sort of understand the coordinates. And the first one I'll draw is from here to here, and then I'll draw one from here to here, and then to the y-axis like that, and to the y-axis like this. Okay? And now let's label these. So this point right here, they've given us is 9 just based on the question. So that's a 9 right there. And this point right here, they've given us is a 5. Okay? So that means that the distance from here to here is 9 minus 5, which is 4. Okay? And then similarly on the y-axis, this point right there is 2, and this point right there, based on the coordinates, is a 5. So that means this distance right here is going to be 5 minus 2, which is 3. And since this is a right triangle, I can figure out that distance right there. Now you can either do it in your head or you can do Pythagoras, which would be 3 squared plus 4 squared is equal to hypotenuse squared. 9 plus 16 is equal to 8 squared. And h is equal to the square root of 25, which is 5. So that is a 3, 4, 5 triangle. Now, very similarly, I'm going to do the exact same thing, but now over on this side. Draw that one, draw that line properly, if I can. And then similarly, I'll draw the lines to the y-axis like that. Okay, so let's now label this one. So this guy right here, they tell you is 15. And this one here, they tell you is A. All right, so that's all we know so far. How about on the y-axis? This one here is 13, and this one here is B. Correct? If I haven't made any mistakes. Okay. Now, I want you to understand that this triangle is exactly the same as this triangle. It's all symmetric. So therefore, we can label these sides 4, 3, and 5. So if this is 4, that means that A minus 15 is equal to, sorry, not A minus 15, 15 minus A. I was on the right track. 15 minus A is equal to 4. So that means that A is equal to 11. We would have gotten a bizarre answer anyways if the other way around. Now, very similarly on this side, that's 3. So that means 13 minus B is equal to 3. So that means B is equal to 10. Okay, so I hope you're convinced of that. And they want us to figure out A minus B. Sure, no problem. A minus B. A is 11. B is 10. So A minus B is equal to 1. So 14, the answer is E. A small island has 2/5 of its surface covered by forest and 1/4 of the remainder of its surface by sand dunes. The island also has 90 hectares covered by farmland. If the island is made up of only forest, sand dunes, and farmland, what is the total area of the island to the nearest hectare? So let's draw a shape. I don't know if it's a rectangle, but it most likely is. And let's divide this now. 2/5. So 2/5 is approximately here, I think. And this 2/5 is this forest. So forest, to write that. Now I don't know the total area. That is what I have to figure out. So I'll let that be x. Let x equal total area. So this forest is 2/5, so it's 2/5 of x. 2/5 of the total area. Now, let's concentrate on this part here. That part, they tell you that 1/4 of it, 1/4 of the remainder of the surface is sand dunes. So 1/4 of this is sand dunes. So that would basically mean, let's see, 1/4 is approximately here. 1/4 of the remainder. All right? So that's sand dunes. So if this was 2/5 from here to here, then this whole thing from here to here is 3/5, right? It all has to add up to x. So 1/4 of this is right there. So this represents 1/4 of this guy. 1/4 of 3/5 x. It's exactly what the question is telling me. And that looks like 3/20x. All right? And Yeah. So this shaded region is sand dunes. Sand dunes. And therefore, the remaining is farmland. And that's what they tell you. So all this here is farmland. And they tell you that's 90. So that's very helpful. Correct? All right, so now we can get a mathematical equation. Our mathematical equation from our formula is x, which is the total, is basically equal to 2/5 x plus 3/20x plus 90. 2/5 x is the forest, 3x/20 is the sand dunes, and farmland is 90. And all of them, when you add them all up, is x, which is our total area. So let's solve for that. Multiply through what we're going to need a common denominator, right? So, we put all the x's on one side first. That should make it easier. So like this. And then now we'll get a common denominator of 20. So 20, top and bottom here, is going to be multiplied by 4. So we got 20x minus 8x minus 3x all over 20 is equal to 90. So this looks like 9x is equal to 90 times 20. And therefore x is equal to 90 times 20 over 9. 90 divided by 9 is 10, so 10 times 20, and therefore that is 200. So x is 200 hectares. So the answer to number 15 is C. How many integer values of x satisfy this equality? All right, so we have x minus 1 over 3 is less than 5 over 7, which is less than x plus 4 over 5. So first, let's concentrate just on that part right there. X minus 1 over 3 is less than 5 over 7. So cross multiply and you get 7x minus 7 is less than 15. 7x is less than 22, so x is less than 22 over 7. And 22 over 7 is approximately 3.1, I think. Yeah. Very similar to pi, it sounds like, actually. All right, now let's concentrate on this one here. 5 over 7 is less than x plus 4 over 5. Cross multiply, and don't make any mistakes. So we get 25 is less than 7x plus 28. So that means 7x is greater than minus 3. So x is greater than minus 3 over 7. And therefore, minus 3 over 7 is what? Minus 0.4 approximately. 0.43, I think. All right, so that means x is greater than minus 0.43, and it's less than 3.1. And what do they want in the question? How many integer values of x satisfy that? Okay, well, how many integers are between minus 0.43 and 3.1? 0, 1, 2, and 3. So that's 4 integers. So the answer to number 16 is 4, which is E. A, B, C, D, E, F, G, H is a cube having side length 2. P is the midpoint of E, F. The area of A, P, B is. All right, so let's label first of all what we know. The cube has side length 2, right? So this is 2. And then they're showing those, which means those are equal. because P is the midpoint of EF. So that's 1 and that's 1. And that's all we know so far. I mean, other than the fact that all the sides are 2. So that is pretty much all we can label so far. No problem. Let's proceed. Now I have to figure out the area of APB, right? So I already have AB, but I also eventually will need to figure out AP and PB, the lengths. All right, so first one, let's figure out PB. Let's concentrate on that guy right there. Okay? So I see Pythagorean relationship, but first it's not that simple. I have to figure out a couple new things. I'll join P to G, and I will first try to figure out PG. So I hope you can clearly see that this is 2, this is 1, and this is a right angle right there. Okay, it's on a curve, but that's a right angle because the base is a square, right? So using Pythagoras, we have PG squared plus 1 squared. PG squared equals 1 squared plus 2 squared. So PG is equal to 1 plus 4, all under the root sign, so it's root 5. Okay, so I'll squeeze that in there, root 5. There you go. But we don't want PG, we want PB. But PB we can get without too much difficulty because BG is 2. So again, we use Pythagoras. PB squared is equal to PG squared, which is root 5 squared, plus BG squared, which is 2 squared. So this looks like 5 plus 4, which is 9. So therefore PB is equal to 3. There you go. 3 right there. So we got 2/3 of the puzzle. Now we have to proceed to try to get AP. All right. So next step is I'm going to stay on this diagram because I hope you understand the continuity of it, that things are going to be similar. So now let's concentrate on HEP. HE is right there, right? EP is right there, and then I'm going to draw a line connecting H to P right there like that. That is also a right triangle because that's a base, and that's basically a square, that's the base. So let's figure out, what do we know so far? HE, of course, is 2 because that's just the side length. So let's figure out HP. HP squared is equal to 2 squared plus 1 squared. Very similar to what we did before. So this looks like 5. So therefore HP is the root 5. So squeeze that in there, root 5 like that. And then now I can figure out AP. Because AH, this distance here, is 2, correct? So using Pythagoras on triangle AHP, it's a little hard to see, it's kind of really narrow in there, but that is another right triangle. We will get AP squared is equal to AH squared, which is 2 squared, plus HP squared, which is 5. So this will be 4 plus 5, which is 9, and therefore AP is equal to 3. So there you go. We got all the pieces of the puzzle. So last step. ABP, I'm going to draw here, like flat, all the way, so you can see. And so this is going to be A, this is going to be B, and this is going to be P. This is 2, this is 3, and this is 3. Correct? Those are the values that we figured out. Now this is isosceles, an isosceles triangle. So if I draw a perpendicular from the top P, or the bottom P, whatever, from P all the way to AB, like that, that will basically be the height of that triangle. And since it cuts AB in half, this will be 1 and that will be 1. So if we call height h, I can figure out h with Pythagoras. We have 3 squared is equal to 1 squared plus h squared. So 9 minus 1 is equal to h squared, and therefore h is the root of 8. So finally, the area of ABP is 1/2 base times height. The base is right there, it's 2. The height we figured out was root 8. And therefore, this becomes root 8. So the answer here is 17 is A. How many 5-digit positive integers divisible by 9 can be written using only the digits 3 and 6? Okay, so you have a 5-digit number like that, and you can only use digits 3 and 6. All right, so 3 and 6 are the only possible, and total. I'm going to make a little table here. Okay, so we can use, let's say, 5 3s and 0 6s. And if I do that, what kind of number am I going to get? Well, it's just going to be this one, 3 3 3, like that. 5 3s and 0 6s, correct? How many of them? Well, there's only one possible way of doing that. How about 4 3s and 1 6? Well, you're going to have more choices. You're going to have something like this, 3 3 3 3 6, 3 3 3 6 3, 3 3 6 3 3, 3 6 3 3 3, and finally 6 3 3 3 3, like that. Okay, so how many is that? That's 5. So I hope you, so far, no problems. How about you have 3 3s and 2 6s? Well, this is going to be a little bit more. All right, let's see. 3 3 3 6 6, 3 3 6 6 3, 3 6 6 3 3, 3. There's so many possibilities. Let's try to keep this in order. 6 6 3 3 3, 3 3 6 3 6, 3 6 3 3 6, 6 3 3 3 6, 3 6 3 6 3, 6 3 6 3 3, and 6 3 3 6 3. All right, I hope these are all different. I think they are. The good news in this question is you really don't need to list them all, but I want to list them all because I want you to understand it properly. So how many did I get? I got 10. All right, now we got 2 3s and 3 6s. Well, the good news is it's also 10 because it's the same scenario here. And we can list them all. It won't take too long. So those are the combinations with only 2 3s and 3 6s. There's 10 of them. And then finally we've got a scenario where you have only 1 3 and 4 6s. So those are pretty straightforward, like this. You just shift that 3 down the road like that. And finally, there you go. 5 of those. And the last scenario, 0 3s and 5 6s. And there's only one possibility of doing that. 6 6 6 6 6 1. All right, great. So we're done. Now we have to figure out how many of these are divisible by 9, right? Now you think, oh boy, do I really have to go through all of these and divide by 9 and see if I'm going to get an integer? That's going to take forever. And the good news is you don't have to do that. You actually didn't even need to list all of these. I just wanted to do that to explain. A number is divisible by 9 if the sum of the digits are divisible by 9. All right? So you can use that to quickly figure out which of these are divisible by 9. So let's first look at this scenario. What is the sum of the digits? 3 plus 3 plus 3 plus 3 plus 3 is 15. Is that divisible by 9? No. All right, let's look at these guys. All of them have the same sum. Why? Because they're all in the same category. 3 3s and 1 6. So all of them have 3 3s. Oh, sorry, 4 3s. Yeah, they're all in the same category that I described wrong. 4 3s and 1 6, right? So all of them will have a sum of, what is this, 18? Yeah. Is this divisible by 9? Yes, it is. All right. So that means all of these guys here are divisible by 9. Let's go to the next one here. These guys. All of these have the same sum. The sum of the digits of all of them. Why? Because all of them are 3 3s and 2 6s. So that's 9 plus 12, which is 21. Is 21 divisible by 9? No. So these guys are out. This one was out. How about this here? All of these have 3 6s and 2 3s. So the sum of the digits for all of them is 18 plus 6, which is 24. Is 24 divisible by 9? No. So those are gone. Now we turn our attention to these. All of these have 1 3 and 4 6s. So that's 3 plus 24, which is 27. Is 27 divisible by 9? Yes, it is. So all of these guys are divisible by 9. And finally, we've got one number here, which is 6 times 5 as the sum of the digits, which is 30. Is 30 divisible by 9? No. So that's out. So of all of these, 5 plus 5, 10 are divisible by 9. So that would mean 18 is D. 3 different numbers are chosen such that when each of the numbers is added to the average of the remaining 2, the numbers 65, 69, and 76 result. The average of the 3 original numbers is. So we will call our numbers A, B, and C. And then let's write out what the question is telling us. If you take the number and add it to the average of the other 2, it equals 65. If you do that again with the different numbers, B added to the average of the other 2 is 69. And finally, C added to the average of the other 2 is 76. Okay? They want you to figure out the average of all 3. So they want you to find A plus B plus C over 3. Correct? All right. So we got 3 equations. Where do we want to proceed here? We'll just add them, I guess. So A plus B plus C over 2 plus B plus A plus C over 2 plus C plus A plus B over 2 is equal to 65 plus 69 plus 76. All right. Multiply through by 2. Okay. 2A plus B plus C plus 2B plus A plus C plus 2C plus A plus B is equal to 2 times this. And this was 210. So let's see, add up all these to get 3A, 4A, 4A, B, 4B, and 4C. Great. Is equal to 420. Divide through by 4, and you get A plus B plus C. 420 divided by 4, 210, 105. All right, great. So A plus B plus C is 105. We have to figure out A plus B plus C over 3. Okay, no problem. Divide through by 3, and that will give you 35. So that is the answer to the question. 19 is B. Square ABCD with side length 2 is inscribed in a circle as shown. Using each side of the square as a diameter, semicircular arcs are drawn. The area of the shaded region outside the circle and inside the semicircles is. All right. So first thing, let's label this diagram a little bit. I don't think we need to label it too much, but we can put a line from the center till the edge that represents a radius. And anything else? We can draw a line from the center to the top there, line from the center to the side, and those are all radii. So the side length of the square is 2. So if the whole side is 2, then this is going to be 1 and this is going to be 1. And of course, this is 1 from here to here. And that means that we can figure out r with Pythagoras using that little triangle. So 1 squared plus 1 squared is equal to r squared. So that means 2 is equal to r squared, and therefore r is equal to root 2. Okay? And then now, to figure out the shaded region, we have to do in 2 steps. The first step is to figure out this guy right here, this shaded region, or the one I've shaded in orange. So I'll call that area of shaded orange. And that is basically the circle, right? This whole circle. And subtract from it the square. And that would give you actually all 4 of those. So it wouldn't just give you this one, it would give you all 4. And then we can divide by 4 to get just one of those. So it's the circle minus the square, like that, and then you divide by 4 to get just this one section right there. All right? So the circle is, of course, just pi r squared. The square is length times width, or the side squared, and that's 2 squared because the side is length 2. And then pi r we figured out was root 2. So root 2 squared is 2. So this is just 2 pi, I got to divide by 4, sorry, like that. So this is 2 pi minus 4 all over 4. Okay? And this can be reduced to lowest terms, pi minus 2 over 2, like that. So this guy in there is pi minus 2 over 2. Okay? Now we get to the next step, which is trying to figure out this gray area. Gray area is what they want. How do you figure out the gray area? Where you take the semicircle and subtract from it this one, pi minus 2 over 2. I hope you agree with me. Now let me label what I mean. This semicircle right here, if you take the area of that and subtract from it the orange part, you'll get the gray part. So let's do that there. Big semicircle is, of course, pi r squared divided by 2 minus pi minus 2 over 2. So let's bring this up here. Pi, what is r in this case? What is the radius? Be careful. I hope I didn't confuse you by using the same symbol. The radius of this semicircle is from here to here, correct? The diameter is the same as the side of the square, which is 2. So the radius here is 1. So the radius, for example, is from here to here, which is 1, the same as that. So don't make that mistake. So no problem. We got 1 squared over 2 minus pi minus 2 over 2. So this just looks like pi over 2. minus pi minus 2 over 2. So pi minus pi plus 2 over 2. And then this looks like just 1. So we figured out that this gray part is equal to 1. Now we have to figure out all 4 of those gray parts. So therefore, all 4 would be 4 times 1, which is, of course, 4. So that is the area of the shaded region, and that would make 20 B.